Possible for 2 to ever come out of this? 3, 4, 5? Yes, 5 can come out, right? Can I plug 0 into this function? Can I plug 0 in?
Yes.
What's your domain? 4 to infinity. Right? Can you plug in 0 into this function? No. Look, plug 0 in. What do you get? Square root negative 4. Oops, can't do that. What I'm trying to get you to see is that you can answer a lot of questions about this function that are difficult to do by looking at this, that are much easier to do by looking at this. Am I making any sense here? I mean, if you just go in there and you just ask someone, hey, look, I'm curious to see if, like, is it possible for me to plug in an x and it spits out 4.78? And someone's going to sit there, well, I don't know. I'm going to have to set that equal to 4.78 and try and solve it. But if you understand, now you know that
it's being moved up 5 and it goes upward because you know the toolbox.
that's right. Oh, as long as you knew what that one looked like to begin with. Because if it were cube root, right, then that would be able to achieve that value. So as long as you're comfortable with it enough, you can answer the question pretty quickly. All I'm trying to do is tie some meaning into why we'd want to be able to graph something quickly. Because you can visually look at it and pick up a lot of information about its domain and range and so on. All right. This is a strange question. Suppose the x-intercepts of a graph are given. So here's what I'm telling you. The x-intercepts of a graph are given. Here they are. Ow, what the hell is that? There is a function that when you draw it, those are its x-intercepts. Okay? First question, A. What are the x-intercepts of f of x plus 4? So this is the graph of the function f. We actually don't even know what it looks like, do we? We don't. So I can make something up here. I could say it does this, and does this, and does this. It's a function, though, so it has to pass a vertical line test. That's what it's saying. It's a function. So this blue part is just something I made up. Well, all I know is that this point and this point cross through the x-axis. That's f, right? Tell me what the x-intercepts of f of x plus 4 are. So how are you getting that? So what does adding 4 inside the function do? Moves the whole thing to the left 4, doesn't it? So it takes this picture f and it moves it to the left 4. So that means it takes both these x-intercepts and moves them to the left 4. So just subtract 4 from each of those. So it would be, this is f moved left 4. So negative 12 and negative 3. Very good. How about the answer to part B? What are the x-intercepts of f of x minus 3?
Negative 8, or negative 5 and 4.
Okay, so that's really moving in the opposite direction, right?
Right.
So it's going to move it to the right. So we add 3 to both of those, negative 5 and 4. You all with me on that? What are the x-intercepts of 2x? Ooh.
Negative 16 and 1.
What? Negative 16 and
Negative
2?
Would it be negative 8 and 1?
What does 2 do to it?
The vertical stretch.
2 inside is going to be some sort of compression or stretching, right? If this point is 0, How do you stretch 0? You don't, do you? How do you compress 0? You don't. Therefore, it doesn't move. Understand? It doesn't move at all. I don't know if you remember when we did the absolute value function, of course when we moved it up, down, left, right, things moved, right? But when we stretched it vertically, remember that that point always stayed there? It did this. Or when we did it the other way, it did this, right? But notice that base point, that x-intercept never moved when we tried to stretch it. And so when you have x-intercepts and you stretch, right, it's like pulling this part down and pushing this part up, this part down, this part up. But these anchor points never move because they're 0.
So it would be the same basic explanation for the last one, for f of negative x?
That's going to be a little different. So C, what do we say? Negative 8, 1? What does, oh, did we talk about what a negative inside is? I think I skipped over that on accident.
We talked about on the outside.
Right here. Yeah, a negative on the outside reflected over the x-axis. A negative on the inside is the y-axis. Sorry, I forgot to mention that. Oops. So if you take this picture and you reflect the whole picture over the y-axis, that means everything that was here flips over there, and everything that's here flips over here. So this x-intercept now comes over here to become 8, and this one flips over to become negative 1. So for this part, you get negative 1 and 8. Yeah? Questions? Let's look at the next example. Given this graph of f, graph the following. So I'm going to go up to the board to do this one. Make this a little bigger. Make this a little smaller. I think I can do that. Yes. All right, so let me get up there on the board. Let's do part A. So the graph is given. Here's f. What is f of x plus 1?
You move the entire thing up one?
Move the whole thing up 1. Do I need to draw that? No. Okay, just the whole thing goes up 1. All right, how about f of x plus 2?
The whole thing goes left 2.
The whole thing moves left 2. So just grab each point 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and then just draw that shape again, right? Negative f of x.
Reflect over the x-axis?
Reflected over the x-axis. What would that look like?
Negative.
So that goes and becomes negative 3, right? Let's see, this one here comes up to here. This one comes up to here. And you could do this for all these points, right? You could just like measure this out and come up here and do that. And the x-intercepts don't move, do they? So something like that. That would be negative f of x. This one would be left 1, down 2. So move the black one over left 1, down 2. Half. Compression, vertical compression or horizontal stretch. It's halving every value, every y value, right? So I'll do this one in red. That means at 0 it was 3. At negative 2 it's 0, so half of that's still 0, so that still stays. Same sort of thing on this side. And then over here, this is negative 3, half of that's negative 3 halves, and over here, same thing. And then we just get like this miniature curve like this. That would be half of f. F of negative x.
Reflect over the y?
Reflect over y. So it's actually itself, isn't it?
Yep.
It would be itself?
therefore we assume without actually having seen the function itself. Yeah.
Well, it looks like I've stopped it, right? So it looks like it's a perfect mirror image of. Okay. That pretty clear? You just want me to give you a bunch of those on the test? That's it. Call it a day. All right. Okay, we have. Can someone erase that? Is there an eraser over there? Here. If you don't mind. There, thank you. Actually, would you mind just taking it the rest of the way? I got some stuff I need to do. No? Okay. Okay, graph these functions using completing of the square. How many of you have heard of completing of the square? When did you use complete? Well, hold on. Let's show hands again. Completing the square. Okay, so some of you, okay. When did you use completing the square? Does anyone remember? When you were factoring, right? And you used it to actually solve quadratic equations.
Yeah.
Yes? You remember this? Some of you, I know you don't, but okay, so if you've used completing the square in the past, what I'm about to talk about is extremely important. Even if you understood completing the square, even if you did, you need to pay attention because we've got a problem, all right? We have a little bit of an issue. So let's just recall what it was. So I'm not even going to look at that problem up there. I'm just going to write that quadratic up there. X squared plus 4x plus 2. If I had come in here and said, hey, let's set that equal to 0, everyone, I said solve this, how would you go about trying to solve this? This was on that take-home assessment. Something like that was on the take-home assessment. You try and factor this, not going to happen. So what do you fall back on when nothing else works with the quadratic equation? The quadratic formula, right?
Yeah.
The negative b plus or minus square root b squared. That always worked, right? That always worked. But you could also use completing of the square.
That takes long.
It takes longer. It's much more tedious. Much more tedious. But it works. And it's a skill that everyone in this class needs to know how to use it, how to do it. And the reason why is not only because you want to be able to solve that, but also because we want to be able to do what we're going to be doing here. And trust me, in calculus, and Cal 1, 2, and 3, you have to be able to complete the square. So if it's this thing that you've wanted to avoid your whole life because you don't like it, you have no choice other than changing your major. That you've got to, if you're going to take more math, you're going to have to be able to complete the square. There's no way around it. But there's a proper way to do it, and there's a dangerous way to do it. So I'm curious to see how you learned it. Right? Here we go. Anyone who remembers it, tell me what I need to do first. Subtract 2 from both sides. Okay. How many of you agree that that could be done here? Okay, so you would subtract 2 from both sides. And what I'm going to do is next to this, I'm going to put a red little mark on the side every time I think what you're doing is correct but dangerous. Okay? That is correct but dangerous. Here we go. I'll come back and tell you why in a second. What's the next thing after you do that?
Factor out of x.
Not for completing of the square. No. Okay, so this is where you have to look at the number in front of x. You take half of it. Always. Do you remember that part? Take half of x. But before you can do that, what must the number in front of the x squared be? A 1. Okay, so you have to check. Do I have a 1 out here? Yes. Okay, now I take the 4 right here. I'm going to write it down over here. I take it and divide it by 2. What is that number? 2. Okay? I'm going to put a little star next to this. This is my first little magic number in completing of the square. Once I get this little magic number, I take that number and do what with it? Anyone? So you remember the half part. That's good. Half of the 4 is 2. You square it. Yes, you square it. And you get 4, and that's my second little magic number. Is this ringing a bell? No? Anyone remember what to do with the 4?
Both sides?
You add it to both sides. Yeah? Y'all remember that? So you take it and you add 4 to both sides. Now you're allowed to do that because you have an equation, don't you? You can always add something to both sides? Yes? Yeah, that's very dangerous, and you'll see why in a little while. It's not dangerous, but it's going to get you into trouble later, in a later class. It's all mathematically correct. There's nothing wrong with this. That's why it's a check mark, but it's just... Okay, so this is the standard procedure for completing the square. You make sure there's a 1 in front of x squared. You take that number, you half it, always half it. Keep that on the side. Take that number, square it for that number you add to both sides. Here we go. Now, what are you guaranteed, those of you who said you understood this, what are you guaranteed about these 3 guys right here? What's guaranteed? They're going to factor into what we call a perfect square trinomial. It'll guaranteed be x and then plus or minus a number squared. In this case, plus 2. Actually, that comes from this number. That's positive 2. That's the number that goes here. And then the right side of the equation becomes 2, right? Negative 2 plus 4. Y'all okay with this? And now at this point, what would you do to solve for x? Square root both sides. So you square root the left side. And when you square root the right side, you have to do plus or minus root 2. The left side becomes what? X plus 2 equals plus or minus root 2. And then finally, to get x, subtract 2 on both sides. So x is negative 2 plus or minus root 2. Those are your 2 solutions. Now, if you would have done the quadratic formula instead, you would have got the same thing. I'll show you that real quick right here. Quadratic formula on this. Negative b, which is negative 4, plus or minus the square root. B squared is 16 minus 4 times what's a? 1 times c, 2, so 4 times 2 all over 2a, so 2 times 1. And that would become, let's see, 16 minus 8 is 8. So we have negative 4 plus or minus root 8 all over 2. How can you rewrite root 8? 4 times 2, and then take out a square root of 4, which would be negative 4 plus or minus 2 root 2 all over 2. And then 2, that's a 1, that's a 1, this is a 2. And you get negative 2 plus or minus 1 root 2, and then over 1. So this is the same answer, right? What's faster? The quadratic formula is much faster, isn't it? But it's the technique of completing the square that everyone needs to be comfortable with. And this way, although correct, has 2 dangerous spots. Okay? All right, so I'm gonna fix this for you, okay? I'm gonna fix it. I'm gonna show you the right way to do it. But are there any questions? Let's go to this. Let's look at this example. The example says, look at this function and complete the square and then use transformations to graph it. So they're giving you this function f of x is x squared plus 4x plus 2. What I need to do is complete the square and then use transformations. So we know that by what I just showed you, that when you do completing of the square properly, you get something like x, I don't know, we had plus 2, right? Squared and then numbers and stuff. I don't know what it's going to turn out to be, but maybe it's like plus 3. If I asked you to graph that, could you graph that? What's the toolbox function? Squared. What has it done? We've moved it left 2 and up 3, right? So we can somehow just turn this into this. We could graph it easily, couldn't we? So let's try and turn that into something like this. So we will complete the square to do that. Does anyone see the first problem, the first issue? It's not set to 0. This is not an equation. And this is the problem you run into in Cal 1 and Cal 2 and in Cal 3, is that if you don't have an equation, you can't do that first step of moving that stuff to the other side because there is no other side. So what I have to do is look at this instead as an expression, not an equation, and still complete the square. So how in the hell do I do that? Well, here's how you do it. I'm still going to make sure that I have a 1 here, which I do, right? Okay, so I've got a 1. I'm going to write it here just to kind of stress to you that it's there. This equals, so that equals this. And then I'm still going to take that number 4. I'm still going to divide it by 2. That's going to give me 2. That's still going to be a magic number for me. I'm going to take that number. I'm still going to square it, which is going to give me 4. That's still going to be a special number, right? But here's the deal. I can't add 4 to both sides because I have no both sides, right? So what I'm going to do is I'm going to realize this is one of the first times this is going to ever happen to you. So enjoy it. You're about to see something you probably haven't seen before. You're going to realize that right there is a 0. We call that a hidden 0. And now we've used hidden things before, like anytime we've wanted to do like something like this, and we wanted to put these together, right? We get a common denominator. And we, like for this one, we would multiply the top and bottom here by what? To get x plus 3, and then over here we would do what? X on top and bottom. These were little hidden whats. Yes, but what is something over itself? It's 1, right? This is like a hidden 1, isn't it? Like sitting next to everything, we realize that there's times 1. Anything times 1 is itself. So we've used hidden 1s throughout our entire mathematical lives. What we have not done a lot of, in fact, most of you probably have never done, is realize that sitting next to everything is not times 0, but plus 0. This is a hidden 0, and this is a much more advanced concept in mathematics, to realize hidden zeros. Some of the toughest theorems that are used in Calculus 1, some of the toughest theorems and formulas that we get in that class, to prove that they're true, you have to realize hidden zeros. It's interesting. And who are math majors? Any math majors? No? Okay. Well, then you don't get to realize a whole lot of hidden zeros. But this one's important. Guess what that hidden 0 is going to be?
0.
It is going to be 0, but I'm going to write it a different way. What did I want to do with this? Didn't I want to have an add 4 to both sides of the equation, but I don't have both sides of the equation? So how can I still add 4 without actually adding 4? Add 4 and subtract 4. And you're going to think I'm crazy, aren't you? Here it is. I'm going to add 4 and subtract 4. Everyone agree that what's in red is still 0? And what's still there? 2 plus 2. I haven't changed the problem, have I? I've just used the fact that there is a 0 sitting next to everything. And now, what are you guaranteeing these first 3 will factor to be? X plus 2 squared, right? X plus 2 squared. So that becomes equal to x plus 2, that quantity squared. But what's still left out there? This right here. These two together, right? You have to put that negative 4 back together with that 2, so you get negative 2. That you can graph, can't you? This is a parabola that's what? Move to the left 2 and down 2. And you graph it.
And I'm just so mind blown on the fact that we've been multiplying things by 1. Is that
That whole time, that's what you've been doing? Yeah. We've always been coming in with that little 1. And it's helped us out quite a bit, right? All right, so this is the proper way to complete the square. Now, if you have an equation, feel free to stick to the way you've been doing it. But I still think this is more valuable if you learn how to do it this way, especially on the next one. Let's do this last one. Do I have time? Yes. Look at this last one. This is kind of like the ultimate whammy here. Negative 3x squared plus 6x plus 1. Same instructions. Go ahead and complete the square on it. And once you've completed the square, you graph. So do you see we have a problem already to start?
It's not equal to 0.
It's not equal to 0. And we have a negative 3 in front of x squared, and we just said that you had to have a 1. So how am I going to get that negative 3 out of there?
You divide by negative 3?
If it were an equation, that's what we do, right? We divide by negative 3. But it's not. It's an expression. So you can't just like divide through an expression by negative 3 and still have the same thing. So I'm just going to be a little clever here, because that's what math people and engineers have to be, is clever. I'm factoring out a negative 3. I'm allowed to do that? As long as when I push it back through the parentheses, I have what I started with. So when I pass this back here, do I get this? Yeah? If I do negative 3 times negative 2, I get positive 6. I get that, x. And if I do negative 3 times negative 1/3, do I get positive 1? Yes. So do you see what I've done there? Still completely okay. I'm like, I haven't broken any algebra rules here. Now what I'm going to do is I'm just going to focus all my attention right here and act like that was the problem given to me and that there's a 1 in front, right? So if this is a 1 now in front, we're going to look at this number, negative 2, and take half of it, which is negative 1. That's one of my special numbers. And then the other one is square it, which is 1. That's my second special number right there. Any questions? Go ahead.
The negative.
Negative 1. You're taking negative 2 and you're halving it. So negative 1. Yes?
Okay, so what purpose, like, I'm still kind of confused. What purpose do those first and second numbers that you're getting do for you? Like that negative 1 and that 1?
Okay, this number is going to be what I use for my hidden 0. Okay, like in the last problem I had a 4 here, right? So I added 4 and subtracted 4.
So this one you're going to add 1.
Add and subtract 1. This number is what's going to be in the parentheses with the x, the square thing. I should do it this way. X, and then it'll be minus 1, that quantity squared. You'll see it when I do the next step.
Can we just skip that step?
What's that?
Can we just skip that step and go straight to x1?
I would be real careful. You'll see, because the negative 3, I'm just concerned about the negative 3 and how you would treat that. So maybe, but look, if this is negative 3, right? Here's a set of parentheses. I'm going to realize my hidden 0 right here behind this 2x is where my hidden 0 is going to be. So right in here is where I had plus 0, right? So I'm going to write down x squared minus 2x, but my hidden 0 I'm going to write in here using this number, which is going to be plus 1 minus 1. Do not do minus 1 plus 1. It's plus 1 minus 1.
Are you always going to do plus the?
Yes, always plus than minus for completing of the square.
Yeah.
And then what's still in there next to this? Minus 1/3. Like that, right? Now, I had more markers, other colors. I'm guaranteed that the first 3 terms are going to be a perfect square trinomial, right? This right here, these 3 are going to be a perfect square trinomial. And they will be, this is the number that's going to dictate what's in that parentheses. So just this in blue is x minus 1, got it? Squared. Now what's still in here? Negative 1, take away 1/3, negative 4/3, right? But doesn't that all still live inside this parentheses with the negative 3 in front? Do you see the thing that I thought might be dangerous there? I don't know if you would have picked up the negative 4/3. Maybe you're okay with that, I don't know. Now, I need to get rid of the parentheses. So I'm going to distribute negative 3 back through. I've got to multiply it here, and I've got to multiply it here. So let's talk about multiplying it times this. Can the negative 3 go inside of this? No, because you've got to do squaring before you can multiply, right? So it's just going to sit out in front of it. Negative 3 sitting in front of x minus 1 squared. Then you're going to do negative 3 times negative 4/3. What will happen there? Negative 3 times negative 4/3. It's going to be a positive, right? Positive what? 4. That's it. It's a parabola, right? Squaring function. It's been moved to the right one. It's been stretched vertically. It's been flipped over the x-axis. It's been moved up 4. Got the idea? You learned something today. You have a question?
How did you get 4/3?
How did I get 4/3? Oh, right here. Remember that minus 1 that came off of the plus 1 minus 1? I'm just doing negative 1, take away 1/3. All right, so you have to get a common denominator. Negative 3/3 minus 1/3. So you just turn negative 1 into negative 3 over 3. And then just put them together. Yeah? All right, sign-in sheet went around. Yes? Who needs to sign in? I think we're good. I'll see you on next time we meet, Thursday. Yes. Let me turn off the video.